Okay, for this question, first up I guess we can try to solve for alpha. Now PQR is 128, PQR, so that one is 128. Okay, so opposite sides of cyclic quadrilateral, so it's going to be 180, so alpha is going to be 180 minus 128 equals 52 degrees, and I'll write that 52. Now angle ROP is going to be double that, because the angle at the center is double that of the circumference. So it's going to be 52 times 2 is 104. So I can write that in there. So that means that for this quadrilateral of ROQP, that it has to add up to 360. So we're going to have the gamma and the y equaling to what is left over. So it's going to be 360, take 104, take 128. 104 and 128 is 232. So 360 minus 232 equals 128. And knowing that this equals that, the following working out will ensue, and that would be the working out you end up getting. Obviously gamma has to be the small number because 5 of those end up being 3 of the bigger number. You could also have used simultaneous equations, which I'll do in red. So you change this to make it equal 0 for your first line. Obviously 3 of these plus 3 of those will end up getting 3 times your normal angles. So 128 times 3, 384. You do top line, add bottom line, that will get you 8 equals 384. And when you do your 384 divided by 8, you'll get the same thing as what we got before. 4, 6, 8, your 48 equals your gamma. And then from there you'll be able to figure out your y as well. So that's how we solve that one. The converse of the theorem will be when opposite angles in a quadrilateral are supplementary, the quadrilateral is cyclic. Now for the question down here, prove by a contradiction that the converse we just wrote is true. So we have to assume that we have a quadrilateral that does have supplementary opposite angles but is not cyclic, such as JKLN. So that's the one with the point that's going on the outside there. And a way that we would prove that would actually be that the opposite angles of N and K have to be 180 degrees. And therefore the angle N is going to be 180 take angle K. But the thing is, we'd say the same thing for the cyclic shape JMLK. So that actually means that angle M would have the exact same value. But this isn't possible because for this to have occurred they would be parallel, and therefore the JMN triangle wouldn't exist because it'd be going over, you wouldn't be able to form a triangle with the parallel lines. Because it does exist, it clearly means that, it does sort of prove that you can't have supplementary angles and not be cyclic.